Hey all, 2.6. The title is Multiplying Binomials. Why is that always there at first? I guess there's a big clue, or more than a clue, in the title, but let's kind of build to that, shall we? So here's the kind of stuff we've been doing in recent sections. In this chapter, we were doing stuff like this, which is a monomial times another monomial. So in each set of parentheses, you could say is a monomial. And we did that kind of thing, right? And remember that even though these are technically separated into two monomials, like each monomial in its own parentheses, and it's this whole monomial times this, everything's being really multiplied together. 3 times the x squared times the y times 8 times x to the fourth times y to the fifth. There's no distributing here. No distributing. What was that? No distributing to do, and it's just like the 3 times the 8 and x squared times x to the fourth to get that, and then y times y to the fifth to get y to the sixth. But over here, you could say that this -4 is a monomial, but this bubble, this 5n minus 9 in parentheses, is a binomial. So this is technically a monomial times a binomial, and this is where we need to do the distributive property. -4 times 5n is -20n, and then -4 times -9 is +36. Similarly, over here, if you want to think of the 2x squared times this bubble, you could say that 2x squared is a monomial, but this polynomial in the parentheses would be a trinomial because there's 3 terms. Once again, it's the distributive property. 2x squared times 6x to the fifth would be 12x to the seventh, because 2 times 6 is 12, and x to that power times x to that other power, adding the powers. And then 2x squared times x squared is 2x to the fourth, adding those powers, and then 2x squared times -7x is -14x to the third. So that's what we've been doing, but we're going to do some examples that look like this. And basically, what is this? 2x plus 5 is a binomial. X minus 3 is a binomial. So how do we do this? Okay, well, let's see, probably a good way to view this is where, as we build from this stuff, right? Well, this entire bubble is being multiplied to this other entire bubble. These two binomials are being multiplied together. So think of it this way. If there was just a 5 out in front of this x minus 3, if there was only a 5 out here being multiplied to the x minus 3, you would distribute it, right? Or if there was only a 2x out in front and being multiplied to the x minus 3, you would distribute the 2x. Well, guess what? Both of them are out in front being multiplied to the x minus 3. So we're going to distribute both of them. We're going to distribute the 2x, and we are also going to distribute there we go. And we're also going to distribute the 5. So look at all that distributing. It's like the distributive property on steroids a little bit. So 2x times x is 2x squared. 2x times -3 is -6x. And then, so separate terms. Okay, we distribute, and we just like distributive property this whole time, leading up until now. And then we're also going to distribute the 5. 5 times x is 5x. Positive 5x, of course. Positive 5 times positive x. and then positive 5 times negative 3 is negative 15. Okay? And yeah, so that's how we multiply those two binomials together. Just distribute both of these guys to the other bubble. And what do you think? There's another box. Why? I mean, what else is there to do? Is this not a good final answer? What else could we do to simplify? Well, hopefully you're noticing that these two terms right here, negative 6x and positive 5x, those are like terms. So we can combine them to be negative 1x or just negative x. And now it's done. And I don't know, as we look to finish this off, there's going to be this at the end, but these next couple of examples are not going to be anything, different. Like, there's nothing new for me to say for these next couple examples, other than what I could say for this one as well, which is this, you may have already heard a teacher call this FOIL, or I'm gonna mention it. And if you ever hear FOIL in the future, whether it's from me or anyone else, this is what it's talking about, because distributing the 2x and then distributing the 5, a lot of teachers and maybe even a lot of textbooks refer to that as FOIL, because check it out. And I mean FOIL. Yeah, sorry, I hit the microphone. So if you want to write this down as well, it's kind of like a memory trick that summarizes all of this distributing. Let me say that again. It's really just a memory trick that summarizes all the multiplying, all the distributing we just did to get this. Because check it out. 2x times x, that is like the firsts. It was the first term in each bubble. So 2x was the first one in this bubble. X was the first one in its bubble. So 2x times x, that was the firsts. So that's the F. Then 2x times negative 3. The O is for outers, because 2x and negative 3, those are like the outside ones, the outer ones. And then we went to distribute the positive 5, starting with 5 times x. Those were the inners. Those were the two inside inner ones. So that's the I. And then we had to do positive 5 times negative 3. That's the L, which stands for the lasts. So 5 is the last term in its bubble, and negative 3 is the last term in its bubble. So there it is. That's FOIL. So let's see that in action here. Even though we are distributing, right? We're just distributing the 4x. That would be the firsts. 4x times 3x is 12x squared. The outers, so the O in FOIL, 4x times negative 2. Well, that's negative 8x. And then we got to do the inners. Negative 1 times 3x is negative 3x. And then the lasts, the L in FOIL, negative 1 times negative 2 is positive 2. And then once again, after that, you should notice, and this happens a lot with FOIL and, multiplying binomials together, it happens a lot that you're going to have like terms to combine. In fact, it happens a lot where they're right here in the middle, these two middle terms. Negative 8x and then minus 3x, they combine as like terms to become negative 11x. So that's the final answer right there. The 12x squared just drops down. The plus 2 just drops down. Nothing combines with those. That's the final answer. And again, as usual, pause if I'm moving to the next page too fast. But yeah, I told you, like, nothing new in this example, okay? We're going to do all of this distributing, but the firsts, what's x times x? X to the second power. What's x times 3? The outers, 3x. Inners, 8x. Lasts, positive 24. And then these two middle terms combine to be 11x, positive 11x this time. Yeah, firsts, outers, inners, lasts. which is really just all the distributing. Distributing the x through, and then distributing the 8. Next, and again, pause if you need to, but this last example actually takes it up a notch, because this is not a binomial times another binomial. This right here is, you guessed it, a trinomial. So, I mean, again, it's not just the -3 that's out in front here that's going to get distributed. It's also the 2x. So that's exactly what we're going to do. We're going to distribute the 2x to all 3 of these terms, in this other bubble. And then we're going to distribute the -3 to all 3 terms. That's a lot of distributing. It's a lot of multiplying. You cannot afford to get any of them wrong. Any of the 6. Okay? And I think you might immediately understand perfectly that FOIL, first, outers, inners, last, is that going to cover all of this distributing? No. So you can't really call this FOIL. It's like FOIL, but it's more, because there's more distributing to do than these first 3 examples, right? Okay, here we go. Without any further ado, 2x times 4x squared. That's 8x to the 3rd power, because x times x squared is x to the 3rd. All right, now we got to do 2x to the x. So that's plus 2x squared. Now we got to do 2x to the -6. Again, multiplying. So that's -12x, correct? Now it's time. Let's just not waste any wasted motion here. Waste no time. -3 is now going to get distributed. -3 times 4x squared is -12x squared. -3 times positive x is -3x. And -3 times -6 is positive 18. Whew! It's a lot of distributing. But just like before, what is the only thing left to do? Combine like terms that are I wanted to make that all purple. The curtain has been lifted. Oh my god, oh my gosh, oh my gosh, oh my gosh. Yes. So all of these are now together, and they are all, if there's any like terms, we are going to combine them. Any like terms with the 8x to the 3rd? Nope. But 2x squared minus 12x squared, so the 8x cubed just drops down. But 2x squared minus 12x squared is -10x squared. And then -12x minus 3x is -15x. And then the plus 18 will not combine with anything else. So, yeah, that about does it for section 2.6. Thank you for following along.